Today I'll be showing you a geometric proof, or not. Yeah, sure, let's call it a proof. For the formula that gives you the sum of n, a finite sum of the natural numbers. So this is going to be a geometric proof. And let's begin. So we can consider each of these elements here as areas. Let me just show you how would that work. So let me just draw this. It's not going to be drawn to scale, but each of these elements are supposed to be squares. So yeah, this is not perfectly drawn, but each of these are supposed to be squares. And each square has a side length of 1. Okay? So if you want to define this sum right here, this particular sum, we just have to find the area of this region. Well, how do we find the area of this region? Of course, you can just count the squares, but let's not do that. Let's try a quirky way that I thought of while I was about to sleep last night. And this is why I made the video, because to flex, I guess. All right. So we draw this way. We do this, okay? And let me just black out this part. All right. Now, let's not consider this blacked out area. Let's just find the area of this triangle right here. What would the area of this triangle be? Well, it would just be side length 4, all right? And then we have 4 times 4 over 2, base times height over 2, and then that just gives us 8. But however, we also need to consider this blacked out components too. But a simple way to do that, like each of these blacked out components is just half a square, right? So our formula for the blacked out parts, okay, blacked out parts would be, it would include 1/2 times 4 of them. So 4 of these blacked out components, and that would just be 2. Now, this represents the area of the blacked out components because this basically means 4 blacked out components with area 1/2, because each of these squares have 1 times 1 area, and half would be 1/2. So if we sum 8 plus 2, we get 10. And that's exactly this sum here. So 4, 7, 9, 10, yeah. So to reiterate, we can think of this sum of natural numbers as this type of geometric shape right here, where it's just 1 plus 2 plus 3 plus 4. Now, let's find a general formula. Like, we want this in terms of n. And using the same method here, but just generalizing, let's just do 5 by 5. Sure. Yeah, this is not going to be drawn to scale. Oh, God damn it. All right, who cares? Okay. All right, 5 by 5. Instead, we're just going to write n by n. And again, we're going to black out these. Okay? Now, the area of this triangle would be 1/2 base times height, so n times n over 2. And the area of the blacked out parts would be, well, if it's, this is going to be pretty hard to explain. If it goes down n this way, and if it's horizontal n this way, then there's going to be n blacked out parts with area 1/2. So the total area of the blacked out parts would just be 1/2 times n. 1/2 represents the area of each little black square. I mean, each little black triangle would have an area of 1/2. And there's n of these black triangles. You can just know that intuitively. Like, so this is a 5 by 5, right? And there's 5 black triangles. If it was 6 by 6, there'd be 6 black triangles. And then we have this formula. And the total area would be the sum of these. So n squared over 2 plus n over 2 equals n squared plus n over 2 equals n plus 1 over 2. And that's the exact formula we found there. Thank you.